All right, Hill-Huntington's method. This is our final method we're going to learn. So in this particular topic, we're going to distribute 50 representatives. And first step is going to be to add up our state populations like normal. We get 1,000. And then our standard divisor is going to be 1,000 divided by 50 as usual, and we get 20. And then our standard quota is going to be what we normally do, 333 divided by 20, 472 divided by 20, and 195 divided by 20. So that's a 16.65, a 23.6, and a 9.75. All right. We're going to modify our quota so this process works, but I always like to try the actual number first. So for example, let's try 20. And so obviously if we're keeping 20, then these values are going to be exactly the same on this row. If we modify the quota, then we're going to be doing 333 not divided by 20, but say like 20.1 or something. So these numbers would be different. But let's just try 20. Let's see if 20 works on this problem. So I'm going to just rewrite my 16.65, my 23.6, and my 9.75. All right. We have to find the geometric mean. The geometric mean requires us to find values of n and n plus 1. N is the quota rounded down. Okay, so round the quota down and call this n. So for example, here n is equal to 16. See how I'm rounding this down? Okay, what's n going to be here? N is going to be this rounded down, which in this case is a 23. In this case, rounding 9.7 down, I get n equals 9. Well, the geometric mean has us do the square root of n times n plus 1. Well, what's n plus 1 going to be? Well, my n plus 1s are going to be, in this case, we're going to have, that's going to be 17. In this case, it's going to be 24, and then 10. You see how I'm just adding 1 to that number? That's what n plus 1 means, adding 1 to n. So our geometric mean is going to be, in this case, 16 times 17. In this case, it's going to be 23 times 24. And in this last case, it's going to be 9 times 10. So let's do that math. So we're going to do the square root of 16 times 17. Make sure they're both under the square root. Here I get a 16.49. And then the next one, square root of 23 times 24, I get a 23.49. And lastly, square root of 9 times 10, or square root of 90, is a 9.48. Okay, and we're hoping that this works so we don't have to modify our quota. All right, now this is really important, this next step. It says if the quota, okay, is bigger than the geometric mean, then you're going to give the state n plus 1 representatives. In other words, you're going to round it up. If not, you round down. All right, so let me use a different color here. We're comparing these two things. Which one's bigger? Okay, the quota is compared to the geometric mean, so this says that we round up. Okay, so if the quota is bigger than the geometric mean, you're going to round up. If your geometric mean is bigger than the quota, you're going to round down. Okay, in this case, our quota, the 16.65, is bigger than our geometric mean. It's this case right here. So we're going to round up. So that's going to give us a 17. Okay, 23.6 is bigger than a 23.49. See how the top is bigger? So we're going to round up again, and that's going to give us a 24. Okay, and here again, our top is bigger. The 19.75 is bigger, so we're going to round up. So that's going to be a 10. And unfortunately, when I add this up, I get 51, which is not what I want. Okay, so if you want to rewrite this, if you don't like those two phrases, you could say if the top is bigger than the bottom, by top and bottom, I mean this is a top, this is a bottom, you round up. If your top is smaller than your bottom number, you're going to round down. All right, now folks, obviously this didn't work, right? We actually have to erase this entire bottom part because we got 51. So we need to modify our quota. So let's try something new. All right, let's go ahead and try 20.1. Okay, so I'm going to do 333 divided by 20.1. I get a 16.56. Okay, now the next one, do 472 divided by 20.1, and I get a 23.48. That was this divided by that. And lastly, 195 divided by 20.1. That gives me 9.70. Okay, so now to find the geometric mean, I'm not going to go through all this mess, but it's basically going to be this number, 16 times 17. The next one's going to be this number, 23 times 24. And the last one's going to be this number, 9 times 10. All right, so what does that give me? Square root of 16 times 17. That gives me 16.49. And you might want to maybe try that. Just make sure you know how to do the square root of two numbers. It's pretty easy on the graphing calculator. All right, next one, square root of 23 times 24 is a 23.49. Whew, slightly bigger, you see that? And this last one becomes the square root of 9 times 10, which is the square root of 90, which is a 9.48. Remember, if the top number is bigger, we round up. So that's the case right here. The top number is bigger, so we're going to give this a 17. Here, actually the bottom number is bigger, so we're going to just round down to 23. Okay, and then here our top number is bigger, so we're going to round up to 10. Adding these three numbers together, we do get 50, so our modified quota did work, and we are done. Now, I know this is the longer process, but you certainly can do it. Thanks for watching. Bye.